Hello everyone. So today in this video I'll be covering up a problem from Jaan kalda kinematics, that is problem number 33. You can see that it's marked with orange color, which means it's a difficult problem. The problem involves a bit of kinematics and wave motion. First part can be solved by basic knowledge of just of vernier calipers, but second part you need some special concepts to know before solving it. So without further discussion, let's get started. The question says there are two comps which are depicted in the figure below. The figure renders the proportions of the comps correctly, and the scale of the figure is unknown. The gray comb moves with speed of 1 centimeter per second in the direction as shown in the figure, and the black comb is at rest. Find the speed and the direction of the dark strips. Okay. To do the first problem, I will show you two methods. The first method is just basic vernier caliper method. What the question says is that you have a dark strip as shown in the gray color, and another dark strip is just adjacent to it here. Now I consider this one black and the spacing between this, that is this as the one black unit, that is 1b, and the between the gray scales, that is between this one and this one, is 1 gray. I can also write this as to be 1 gray and this has to be 1 black, right? Now observe one thing. Considering these two, this one, and now I am taking this one. Okay, so you can see between the two crests, we consider one black unit. How many crests are there? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So basically 1, 2, 3, 4, 5, 6, 7, and 8. 8 black units is equals to, now what is, how many gray crests are there? So observe one thing. Here is one gray, second, third, fourth, and fifth. Here it's hidden. Sixth, seventh, and eighth. So if you find the distance, you will compare the distance. Then you will get seven whites, seven gray scale. Now for simplicity, what I am doing, I am considering one black unit to be 1 centimeter. This is a vague assumption. You may assume, you may think that why I am considering to be this, that one black unit is 1 centimeter. It is nothing but just to simplify the calculation. So I can say that one gray unit to be 8 by 7 centimeters. Now observe one thing, that these two are symmetrical. These two are basically symmetrical. So can you find a distance between this end and this end? You have to find basically this distance. So it will be basically um, what can I write? Since the gray comp is moving towards the right direction, basically I have to cover this much of white distance. If you try to evaluate it, it will come out to be 8 by 7 minus 1, that is equal to 1 by 7 centimeters. You may wonder why, because the grayscale has to move this distance, so you have to basically find the distance between these two edges, and here to here, right? You can do it by using basic manipulation, that is least count of the vernier caliper is 1 by 1 main scale division minus 1 vernier scale division, where 1 main scale division is equals to 1 black unit and 1 vernier scale division is 1 gray unit. So it will come out to be 1 by 7 centimeters. So now if it covers this distance, what will happen basically is that the wave will move here. Wave will move in the adjacent black strip, but in the opposite direction of the motion of the grayscale. So basically If the grayscale moves by plus 1 by 7 centimeter, the wave will move by minus 1 centimeters. Now this to go 1 by 7 centimeters, it will take 1 by 7 seconds. So the velocity of wave will be minus 7 centimeter per second. And that's the answer to the first problem. Now coming to the second problem says that we have the same situation and the same conditions before, except that the black comb is under a small angle of alpha with respect to the gray comb. For numerics, consider alpha to be 0.1 second radians. Now to solve the problem 2, we are not given any such kind of diagram. So what will be my basic approach? For this, we need to introduce some concepts of wave motion. We know that for any wave motion or for rarefaction, we consider a sine k r vector, k dot r vector minus omega t. Now, in the first case, for the first problem, during the first method, I consider the displacement of the compressions. Now, what I'll do that I'll be considering the displacement of the rarefactions. Basically, the black strip and the gray strip will coincide with each other, and this will correspond one rarefaction because here you will get white spaces. So this is suppose my equation for the grayscale, and grayscale be k1 and a sine k2, sorry, for grayscale it will be k2 vector dot r vector, and for black scale it will be k1 vector dot r vector minus omega t. This will be for black scale. Now for rarefaction, we know that gray into black, the product of the wave function should be 1 because they are coinciding with each other and they are already at the crests. Hence I can say that k2 r k2 dot r minus omega t is equals to 2n by plus pi by 2. Similarly, k1 vector dot r vector minus omega t is equals to 2m pi plus pi by 2. Now observe one thing, the black scale is not moving at all. So black scale is just contribute to k1 dot r vector. K1 dot r vector basically represents a kind of a standing wave, and omega t basically represents the movement of the wave. So I can just remove the omega t term for the black scale, and since the wave is moving along the x direction, so I can just write it x. Here also it will be x. Hence I can say that k1 vector minus k2 vector is equals to 2m minus n pi minus omega t. And if you rearrange it, you will get k1 vector minus k2 vector dot r vector, because the wave is moving towards x, I am considering r vector to be x only, plus omega t is equals to 2m minus n into pi. So this is the condition for the standing for the group velocity of the wave. Hence my velocity of wave will be omega by k1 minus k2, and this will be minus because the wave velocity is written as omega by k1 minus k2 if the equation is omega by if equation is kx minus omega t, we write velocity equals to omega by k. If equation is kx plus omega t, I will write equation velocity to be minus omega by k. Now you may be wondering what will be the wavelength. Wavelength is proportion inversely proportional to the k value. Basically I can write omega to be some minus omega, and considering the magnitude I will be just taking mod here k2 minus k1, and so omega by k2 by mod k1 by k2 minus 1. Now k2 is for the grayscale. So for the grayscale, we know that omega by k2 is 1 centimeter per second, and k1 by k2 can be written as lambda 2 by lambda 1 minus 1. We already said that one black scale is equal to one grayscale is equal to 8 by 7 black scale, or 8 black is equal to 7 gray. If we consider one black to be 1 centimeter, so gray to be 8 by 7 centimeter. So let these be wavelengths. These are the wavelengths. So lambda 1 is 1 centimeter, lambda 2 is 1 by 7. I can write it as 1 by mod 8 by 7. Sorry, it will be 8 by 7 minus 1, which will get to be 7 centimeters. What is lambda 2? Lambda 2 is 8 by 7. Lambda 1 is 1 centimeters in centimeters respectively. So my result will come out to be 7 centimeter per second. This is the solution to the first part. Now for the second part, I have to introduce some other concepts, like I have to introduce dot r vector here more specifically. To solve second part, again the answer will be omega, magnitude will be omega minus mod k1 vector minus k2 vector. Here, since k2 vector, this grayscale is inclined at an angle alpha, so k2 vector can be written as k k2 vector can be written as k2 cos alpha I cap. I can write it as k2 alpha I cap plus k2 alpha j cap, and subtracting with k1 I cap will get the, and finding the magnitude will get the answer. So it will be basically under root k1 minus k2 whole square plus k2 alpha whole square. Since we are taking the consideration of the magnitude of velocity of the grayscale, the direction is involved with k2. Now taking out the k2 square from the denominator, I'll get omega by k2 as 1 centimeter per second under root 1 by 7 whole square plus what is alpha? 0.1, I guess. It's written alpha to consider 0.1. So basically it will be 1 by 7 square plus 1 by 10 square. Doing the further calculation using a little bit of calculator, I will get, mm, just a minute, and this will come out to be nearly 5.73 centimeter per second. So this is the answer to the second part. Of course, we are taking the magnitude, we are not taking the direction. If we take the direction, it will be negative direction. We can also verify from the first part the analysis we did in the first part about the calculation using the vernier calipers. The same analysis we are doing here. So we can say that direct with along with direction will be minus 5.73 centimeter per second along the I cap. Hope you enjoyed it and learned something new. The wave motion analogy was pretty interesting in this concept and something new to learn. One must also approach using vernier calipers. Well, vernier calipers for the second part is a little difficult, so I'd rather say continue with wave motion. Hope you enjoyed it. Thank you and have a nice day.